So good afternoon, my name is Victor Moreno. I'm a distinguished engineer with the enterprise networking team. We're the ones that build SD-Access, SD-WAN, the catalyst switches, all the routers where you activate SD-WAN. So one of the things that we've been working on is integration of the multiple domains and trying to bring things together so that you can start operating this in the areas that matter as if it were one network, right? And that includes all the domains that we own, plus all the other domains that Cisco produces, and some that we don't even own. So what we're going to talk about is the key concept of what we're doing. Is it a controller of controllers, or what is it that we're doing? And I'll show some of the integrations that are currently in flight. And that's going to take our half hour. Think of this as a journey. This journey is taking us in small steps of having pairwise integration so that we can build a foundation to get that end-to-end experience that we're looking for. So the premise of intent-based networking, very simple. When you are expressing intent, you're usually focused on what is it that you're trying to achieve ultimately, which is have users or things get to their applications. And this simplistic view of things would lead to think of the network as just a very simple line, right? And hopefully we can get to a point where it's similar to that line. Our reality is a little bit different, and this is what we're trying to abstract. We have access onto the network from many different places, in many different forms: wired, wireless, LTE, on-premises, in campus or branch, coffee shops, etc. And on the other side, we have our applications no longer hosted in one brick and mortar data center, but spread all over the cloud and moving back and forth. So our SD-Access solutions and SD-WAN solutions are our means of getting the footprint to service all of these different points of connection into the network. And it's also our way of procuring a footprint to deliver pervasive security as we go across all of these different connectivity areas. So we want to provide this secure experience with performance guarantees in a unified way, even though we have a series of domains. And all of you know how many domains Cisco is able to produce. We've got OT, campus, branch, data center, cloud, you name it, right? And they all work in their own way. And there's good reason why they've evolved in their own way. Each one of these domains is tailor-built to fulfill certain tasks and achieve certain results. In the campus, you will see that we are very focused on identifying and onboarding devices. It's not a trivial task. The nature of the devices keeps growing and varying. In the data center, we have to integrate with all the tooling and all the ecosystem of different compute environments, whether it's virtual machines or containers, whatever we may have there. This is a science in its own right. And in the WAN, we're doing things like optimizing traffic, choosing over different transports, trying to catalog applications based on performance metrics, etc., creating virtual topologies. So all of these things are very specific to each domain. And due to that, we have tooling that is dedicated to each domain. So we're not in the business of producing one Uber controller to manage all of these. And even if we did, we would then have workflows that are tailored to each one of these missions, right? And then scaling these systems becomes extremely challenging, right? So our direction continues to be to have excellent vertical integration in each one of these domains. However, there are certain things that make sense to visualize on an end-to-end basis, right? Things like segmentation, things like the provisioning of SLAs for different applications, and security. So the domains need to cooperate to satisfy that business intent and produce those end-to-end experiences. And that's what we're focusing on. So what do I mean by that? For example, if I was to create segments, virtual networks, and also microsegments across the campus WAN and all the way into the data center, what would happen without any of this tooling is the minute a user moves from a campus location to another campus location or a branch, what will happen is I'm going to have to manually go ahead and reassign VLANs and do a lot of stitching at the border between the campus and the WAN. The WAN may need to reprovision itself. And none of it happens automatically. It's all very manual, right? So this is extremely challenging, extremely time consuming. Yes?
How do you define business intent? I don't mean where do I configure it and the drop down, whatever, but I mean, how do you define it as a person who's developed the platform? And what I mean by that is now that you've mentioned user or you've mentioned segmentation, so the intent there might be security, things like that.
Yes.
And is that what you mean by business intent? How I want that network to behave?
There's many different facets of it, but in general, in an ITSM environment, you will find that people express what kind of service level they would want for a particular application, the rules that govern the access to that application. It's reserved for doctors, for example, and nobody else in the clinic. So those are the type of intents that we translate to a very simple language that I will show you in a couple of slides. Yep.
Okay. So the intent could be very application specific, like this is the QoS policy I need for this real-time traffic or things like that, or it could be much more abstract, like this group of people should have priority, like you said, doctors or something.
For example, yes. So when you talk about intent-based networking, there is a task of translating that intent into an abstract language that can map directly to network primitives, right? So think of it as a pancake stack of abstraction. Mm-hmm. But I'll show you one of the intermediate layers there. So this is highly manual today. In the data center, same thing. As I move a workload from one cloud location to another, I may now lose all the SLA work that I had done in terms of the guarantees that I was providing in the wide area network. So it's a manual process of communicating to the WAN administrator what is it that we need to do and where the workloads are now. So how do we automate all of that? That's what we're getting at, right? So each domain continues to be very well vertically integrated. There are things that have to happen in each one of these domains, and the better you make it work, the better telemetry you're going to get as well. So what we're focused on is providing those end-to-end experiences, right? And there are a handful of them. Policy is one of them. So we want to be able to articulate policy between users and applications and automate how we render that policy into the network. Some of it might be microsegmentation, which is achieved with ACLs. Right? Those would be enforced at the edge domains, not necessarily in the transit. Some of it may be in the form of virtual networks, which we are going to basically do across the board. So security, segmentation, and service levels. Those are the three experiences that we are automating at first. That would be trailed by some assurance, telemetry, and analytics that is meaningful across the different domains. Right? Today, when you look at them, they are meaningful within the domains. How do we correlate all that information and give you a read of what's happening with your intent? Right?
Will you be going into the assurance part a little bit in this presentation today?
Not a lot. We're going to focus on the automation. Yeah, on the automation.
May I ask really quick though? That's something that I haven't heard in the messaging from Cisco, the assurance part, very much, a little bit. But to me, the closed loop, where you bring the automation orchestration with the intent driving that into the closed loop, where you then have the assurance, which some call, automated remediation, autonomous remediation. Is that something that is happening? I know it's kind of a pie in the sky dream.
Well, it is happening in each domain, yes. So the next step is to correlate all of that in a central manner. So I'll show you where that would fit in the timeline. But yeah, it is very much happening. You must have seen a lot of the announcements on artificial intelligence, which you will hear in the next session. Those are already giving you insights that are cross-domain insights. Right? So that's part of why I'm not talking about it in this half hour, but you'll hear about it in the next half hour. And that's just one instance of it. Now, for us to achieve the collaboration between the domains, we're leveraging normalized APIs in each domain. So a lot of it is interaction at the API level. And you'll see the pairwise integration of the controllers that we're doing in this initial phase. So as an example of a use case where we have doctors accessing medical records or other information that is reserved for doctors, what we'll see here is that a physician may log in with their laptop or over a wireless device, and that physician will be cataloged. He would be identified as a physician, and we will be knowledgeable of the type of device that they're using to connect. That is distilled into the assignment of that physician to a particular group, and that group will have certain rights. We're going to exchange that information with the ACI domain. On the ACI side, we're cataloging all our applications, so we have a full view of what the groups of applications that the physician could consume are, and we're going to exchange that information with the access domain. So now, access domain and the data center domain both have complete information to articulate a policy, which is nothing but defining what the relationship is between a group of users and a group of applications. Okay, can you access it? Can you not access it? And with what kind of service level can you access it, right? So on the ACI side, we're going to use that same policy language to express how we would want it to be accessed. What kind of service level are we going to use? And we're going to transfer that request to our WAN. And then the WAN will honor that service level for those type of applications. In transferring that information, we're also communicating to the WAN important aspects of the application, like which endpoints are servicing that application. So it makes it easier for the WAN to actually classify traffic and identify it as part of that application so that it can prioritize or deprioritize the applications accordingly. So once you've done all of these things, what results is an optimized experience for that physician, right? So that's at a very high level what we're doing. So if you think of this as a journey, we've talked to you several times about how we federate identity between our ACI data center and our SD Access system. We're optimizing that identity federation. So let's see what that looks like. Again, our policies are between a source and a destination, the source being the users, the destination being the applications. And all we're doing is defining a contract and inserting that contract in between them. And then we're going to go ahead and enforce it. As you can see here, the definition of the contract is simply one of having further classification of what kind of traffic we have between source and application. So is it HTTP traffic or something else? And we are going to define a series of actions. The menu of actions keeps growing. So we're trying to leverage this language to the point of talking about the abstractions that we're using to express intent. We're trying to leverage this language to express as much as we can in terms of what we want the network to do. So we would want doctors to electronic medical records to get a gold service, for example. So they're allowed to do it, and they have a gold service. So the contract starts defining a lot of the behavior, right? And it's an end-to-end thing, so we need to define it centrally and push it to the different domains so that it can be enforced. So if you think of the left of the line as the access network and the right of the line as the data center, without doing any of this, you only have the information about the applications on the data center side and only have the information about the users on the access side. We need to exchange the information that each domain has. And it's not trivial to come to the conclusion that these are the groups, so this is very valuable information. So we exchange it. Once it's exchanged, you can author policy in either domain. Okay? So for example, I can author a policy that gives me a service level on the access network, and I can author an access policy on the data center side. Permit, deny, insert a firewall, whatever that my policy may be. Okay? So the result of this is, for instance, the nurses may access medical records, but the accounting group may not, and I can articulate that in both of my domains. Right. Now, we said that we've improved how we do this. Before this release, what we had been doing was communicating all the information about users, groups, as well as the members of those groups, basically the list of IP addresses that belong to each group, over an API. And that's a slow channel, right? So sometimes we would see changes that were lost in synchronicity and being updated at our borders, right? So if you are out of sync, then your policy is out of sync, you could actually breach security, right? So not ideal. So what we're doing is we're preserving the tags in the data plane in this next release, and we are going to be gleaning or reading those tags in our hardware and programming those translation tables right away based on data plane events. We still have some API information regarding the nature of the groups and which virtual networks they belong to, but we are going to be gleaning them in hardware and therefore assisting that API exchange by taking stuff off the data plane so that we don't miss one beat. The reason you want these groups is, for example, if I have traffic returning from my servers out to the consumers, and I need to apply a service chain, well, what happens in ACI is I need to know the source group as well as the destination group. My destinations are connected very far away, so I need to know here which destinations are, members of which groups, so that I can actually derive the destination groups and enforce my policy in here. Okay? So these tables continue to be built. Yes?
Am I wrong to think, isn't ICE used to assign the SGTs?
Yes.
It is? Oh, okay. I didn't see it on the slide, and I was like,
Yes.
see it in the
So
center.
ICE assigns endpoints or ports to specific groups on the access side.
That's the engine that's doing the
Yes.
assignment of the security group tag. Okay.
ACI does a similar function on the application side. So he will take specific ports of the web tier of an application, which is what is exposed to the outside, and assign it to groups.
Perfect.
That translates to a series of IP addresses, right? And what we're doing is building these lists here so that we can regenerate the tags here. The notion of the tag, and the reason we put the tag in the data plane, is so that we can scale the system by distributing the tag knowledge as far out as the edge as possible. And that's why we tag with the source tag only. So when you get to the destination, you can derive the destination for it being directly connected and the source because it's in the tag in the data plane. If you didn't do that, you would have to know all of these tables everywhere.
Yep.
Okay, so that's basically what, yes.
In terms of business application, I know some businesses have their own onboarding process. So you have a homegrown application where I put in my users. How far can I do API calls to the system so I don't have to do it redundantly? So in terms of you have nurses, right? So I onboard this person, they get the virtual deployed and all that. And then can the system call a Cisco system, pretty much, and one plane, it's all done.
That's exactly what ICE is doing. So ICE, think of ICE as the engine that is connecting to all the different sources of truth. Active Directory just happens to be one of them. But if you have a private directory that you need to validate things against, you will access that. We connect with the multi-factor authentication systems and all the compliance systems, et cetera. So ICE does a pretty good job at creating that mesh with all the different sources of truth. So that's where you would do it for the access, and then on the ACI side, that's what ACI does in terms of knowledge of applications. Okay. So that model where we exchange identity is valid whether you are in the data center that is on premises or if you're moving things to the cloud. And what we do is we leverage ACI anywhere so that you get a consistent experience no matter where you move. Okay? Same policy enforcement, same policy model, and same exchange, single point of exchange between the domains. Okay? So now remember how we had our line that branched off into multi-cloud and multi-access. We're starting to simplify it. It's starting to look like a single line. Okay? It's starting to be abstracted as a single line. The same thing happens when I move between an access site and another access site. So if I go from the main campus to a branch, I am going to preserve all my semantics of segmentation. This one's interesting because I need the SD-WAN to preserve those semantics for me. Right? The SD-WAN, being a separate system, doesn't natively or naturally support the segmentation that I've created in the access. So how do I make all of this green and blue orbs look like one network? And that's what we're going to explain next. Once you make it look like one network and carry the semantics, it doesn't matter where you connect, you're going to be subject to the same policy. And again, the connection starts looking like a line. Okay. So if we continue our journey, we federated identity between the data center and the access. And now we include our WAN with vManage, and we're going to extend the segmentation semantics over the WAN. Without the integration that we've worked on, this is what things look like. I have disjoint access domains that have microsegmentation, microsegments, and macrosegments. Think of red as microsegments, SGACLs, and yellow as virtual networks, VRFs. Okay? So without doing anything, I have a totally independent WAN, which is managed on its own. It may be SD-WAN. It may just be your traditional WAN. I can manually stitch VLANs. There's all the tooling in place. I mean, this has been done for many years, right? So I can manually stitch VLANs, map them maybe to an MPLS label, and achieve the continuity of the macro segment. My micro segment's a little bit harder. I have to manually provision all these NNIs. I have to manually also make this system aware of any segments that I have in the access, right? So it's all manual, and the extension of the microsegments has to be done out of band. Okay, so very, very kludgy, right? It's not necessarily streamlined. So what we've done is, rather than having two devices, we've merged all this into one device. So the NNI is gone. One less thing to manage. The next thing that happens is we have knowledge in the SD-WAN of these microsegments so that we can actually take the microsegment labels, and whether we do something with them or not is secondary. The first order of business is to grab that tag and transfer it across so that I have my semantics here. I don't need to reclassify. Okay? So, and if you look at this box can only be managed by either vManage or DNA Center. So we chose to have it managed by vManage, and we define our segments, our virtual networks, etc., in DNA Center and push that to vManage. So we do it once. And now you've created the policy across all of the different sites that are interconnected with the SD-WAN. So this starts looking as one network. Okay? So now I have continuity of my data plane and all my segmentation. This is the next thing that we do in support of making that left side of the picture look like one. So if you look at the menu of workflows that you have in each domain, we have a series of things that we do for wired, wireless, et cetera, in DNA Center that are not pertinent to this end-to-end view. And the same thing in the WAN, we have a series of things that we do like logical topologies that don't pertain to the end-to-end view. But there are some things that are common. So when I create a virtual network, I can create a virtual network that cuts across. I do it once. API calls trigger the behavior in the WAN. And I don't need to do it more than once. Okay? The workflows that aren't common remain within the domain controller. Could we have in the future a single pane of glass where we actually can click on tabs and see these different workflows? Sure, but they're going to be different tabs and different workflows. Right? So we can build it into one. But
Can
yes.
you go back just one slide? So actually two questions. So would we have visibility into the API calls themselves, understanding what's going on? And then two, from a troubleshooting standpoint, it would be nice just to say, all those API calls are going to work 100% of the time. Would we have visibility into the performance of those API calls on both ends to understand, hey, for some reason, I've, made this policy in ACI, I'm not seeing it in vManage. I'm not seeing it in SDA, immediately. But so how do we troubleshoot that layer? So we're obviously have physical layer, all the layers that we're familiar with. We're just adding this API layer into what we manage. So how do we gain visibility into that?
Right. Fair question. So these API calls are transactional API calls, so that's the first part. So when you look at the transactionality of it, that's your first stop to make sure that you're assuring that this is actually doing what it needs to do. The APIs are open and publicly available, and part of our evolution is to provide the mechanisms to actually troubleshoot those calls, to check for synchronicity and things like that. So yes, that has to be an integral part of the system. Okay. So to complete our journey, the next thing that we do is from APIC, we tell vManage what is it that you want in terms of performance. This helps the WAN get better visibility into the application. Without more information, you have to do deep packet inspection and you have to come to conclusions based on maybe reliable data or not. The data center knows which IP addresses, it knows which DSCP values these applications are going to use, etc. So that information is communicated to the WAN. It's also communicated to the WAN what kind of policy I want for it. Is it gold, silver, bronze? And that comes off a catalog that is actually communicated from the WAN to the data center. The WAN system is going to tell the ACI APIC in the data center, I can provide you with this profile, or this profile. Let's just say gold, silver, bronze. With that, I can then author policy in the data center and say, for application A, I'm going to be gold. Application B is going to be bronze. And I just simply write it as a contract. From that point onwards, I receive that information in vManage, and I can enforce the policy based on the DHCP values and IP addresses that I was told by APIC that were going to be used. So that's where we're at today, pairwise integrations, right? Now you can see how these northbound APIs could be used to orchestrate an overall policy and maybe send API calls once from a top-level orchestrator. You can use things that are in the market right now, like Ansible, AlgoSec or Tufin, that we do that for security today, right? So the same model applies moving forward, and that's where you're going to start seeing a lot more of the emphasis on the assurance and the telemetry gathering that we were just talking about.